So good afternoon, everybody. We are here with to welcome you to the SAME Energy and Sustainability COI webinar. It is electrical vehicle infrastructure, and Matt is joining us. Matt, are you ready?
Yes, thank you, Carl. Sorry, everybody hear me okay?
Yes, sir.
All right, we had as always we do tech checks twice actually, yesterday and today, and everything was working fine until 5 minutes before we were supposed to go online. So apologize for the rough start there. Hi everybody, my name is Matt McCann. If you've been on any of these webinars in the past for the Energy and Sustainability COI, you should be familiar with my face a little bit. I am a retired Navy Civil Engineer Corps officer. I, as most Civil Engineer Corps officers, had a heavy focus on facilities management, energy efficiency management during my Navy career, and I joined AECOM about 6 years ago, working in their federal space. I'm currently the Federal Energy and Alternate Delivery Market Sector leads. Welcome. Thanks for joining us for another interesting and informative webinar. I feel like we've had great turnout so far this year, and I'm looking forward to see how many we have ultimately calling in today. As Carl mentioned, we're talking about electric vehicle infrastructure. It should be the first of at least a couple EV-related webinars we have this year. We really want to. It's something that that came up several times during our COI in-person meeting at JETSI. That our community members are really interested in learning more about electric vehicles. What's out there, how can they start the process of really developing a plan for meeting the executive orders related to EVs. Let me see, I'm going to take care of a couple administrative items here before we get going. First of all, hopefully you can hear me. If you are trying to connect through a VPN and it's not working, please ditch the VPN. It should work more smoothly. If you have audio issues, maybe you can see my lips moving, but you can't hear what I'm saying. Follow the instructions there for troubleshooting. Through the webinar, Brad's gonna present, and then we'll do Q&A at the end. If you have questions, please post it in the Q&A tab. We should have plenty of time. You can also upvote questions there if you see something interesting that somebody else is asking and you want to help bring it to the top of the list. And as usual, we started recording right at the beginning, so we captured our technical difficulties clearly at the beginning of this. So awesome, that's awesome. Let's see, I'll do a short update on the COI at the end, but just know that we will continue to present topics that are of interest to the community, and are generally for the year, we're kind of really generally trying to connect to the things that the administration thinks are important and have come through in the executive order 14057 and the funding bills that are the infrastructure bill, and whatever else might come out of Congress in the future. As always, we like to do a little poll here to see who's on the call. So please vote there, and I will loop back to that if I remember at the end. I tend to forget, but it's good to know who's on the call. We'll give that to feedback for Brad and future presenters, so we know who the kinds of people that we get on these calls. So moving on to the main event. Hold on one second. Why do I have the wrong script up? Brad Blickendorfer is with us from Trans Systems. He was proposed and nominated by Daryl Moser from Trans Systems, who participates in our COI leadership team. He has been with Trans Systems for 23 years, designing and developing electrical distribution, telecommunications and other electrical and mechanical related projects. So he is here to talk about electrical vehicle infrastructure and some of the challenges that that facility managers will be facing. Brad, please take it away.
Okay, so good afternoon, everybody. My name is Brad Blickendorfer, and get to the right slide here. And as Matt had discussed, I'm a graduate of the University of Pittsburgh here in Pennsylvania. I've been with Trans Systems for quite a while now. A little bit about our company. Trans Systems is a little over 1,000 people. We have 38 offices spread out all over the country. And we've been doing a good deal of federal work here, spanning 45 states and 26 countries over our history here. And we do a lot of work with just about every branch of the federal government and military. So we sort of understand what's going on, and hopefully we can explain some things here to you. So what I wanted to talk about today is trying to keep it at a sort of a high level without getting into the weeds too much. I can get into the weeds, if you guys want, that's fine. But what I'm trying to get to is we have a problem with adding EV charging to facilities, buildings, and what the infrastructure sees from an electrical standpoint. And I'm going to go into some calculations. I built a case study on a fictitious base that we can go through, see what some of the impacts are, see what some of the solutions are. And some of the stuff will look a little bleak, but there are some ways to counteract it, and there is a light at the end of the tunnel for this stuff. So with that, our agenda is going to be, first off, what our issues are. I'll go over with you what the assumptions are that I made for our case study. I will discuss at a high level the different charger types and why we kind of set as to where we are, and then what the impacts are from an electrical standpoint for the chargers on the infrastructure. Along with that, we'll go over a little cost calculation, and then what all this means for the buildings, getting the buildings up to speed, and how a facility or a base or a facility can go about the steps to mitigate the issues and get to where we need to be at the end. So hopefully this makes sense to you guys, and please feel free to ask questions as we go. So first thing, So first thing is, what are we up against in our issues today? There's two biggest things there were two executive orders handed down that one says by 2035, all government agencies will use zero emissions vehicles, which are electric vehicles, hybrids, or fuel cell vehicles by the year 2035. So all fleet vehicles by 2035 will be EVs. The other executive order, more of a goal type thing, is they want everybody to be buying 50% EVs by 2030. And that may be more of an implication than the fleet vehicle implication, but we can go through that and see. But those are the two big glaring issues that we have today. So at a high level, what does that do to us? Buildings, obviously, they were never designed, especially some of the older buildings, to handle the increased load you're going to see from EVs. Then the campus electrical systems powering the buildings, what are they going to see, and what do we have to do to upgrade those as it all snowballs down the chain? And then further yet, what happens on the utility side? What kind of coordination do we have to do with the utility? Can utility even give us the power that we're asking for, as everybody's going to this same end result? The utility has to be able to keep up with that. And we were already hearing about the rolling brownouts, blackouts in different areas, and what's going to happen there as everybody goes towards this EV long-term strategy. And then the last thing is what obviously is a big driving factor for us, whether it's fortunate or not, is cost. both first cost to get stuff installed, and then what does it cost to maintain the stuff and pay for the electrical usage as time goes on. And it's rather significant. So my assumptions for my case study is I came up with a fictitious base considered of 1,000 personnel that occupy the facility on a daily basis, working, living, whatever. The base utilizes, just for our roundabout estimate here, 10 buildings, each one supporting 100 personnel. So I understand there's vast differences with what buildings truly are. Some are maintenance buildings with a few people but have a larger electrical load. Some are office buildings that have a very large occupancy but don't necessarily have a ton of electrical usage. Trying to just standardize it for means of discussion here to 10 buildings, 100 personnel apiece. Our base has a 12470 campus loop that is owned by the facility. It's not owned by the utility company. Our base in our little model here houses 500 people of the 1,000 on the base. Now, the reason I'm doing that is, as people live on base, they can plug their cars into their house at their base. The other half are coming from offsite, may have to travel a larger distance, may need to charge at the base while they're there working. But it gives us a little bit of a diversity of not having all the charging going on in an 8-hour period. It spans it out over 16 hours and still maintains sort of how we're going to calculate this out. Our base has 300 fleet vehicles, which will all be EV in our calculations. Maybe too many, maybe too less, not enough. That's what we're going to pick. And then to accomplish this, we're using level 1, level 2 chargers. We're going to focus on the level 2 chargers because, again, we can sort of use diversity to figure that the level 1 chargers that people may utilize at their house are going to be absorbed into the overall calculation. So why level 2 chargers? They're the most flexible charger to use. They can be used in a house. They can be used in a commercial space. They take a 60 amp 2-pole feed, 11.5 kW a piece. It's not an overwhelming amount of power per charger. They gain about 25 miles of driving per hour charging. Normally a car will pull in, be able to charge in an 8-hour period. The level 3 chargers, although they're great, they can charge much faster. The overall electrical usage is the same, whether you're using 4 level 2 chargers or 1 level 3 charger. A watt is still a watt, still use the same amount of power transfer. But the level 3 chargers have their own implication, and most of it is logistics. If you have an office building with 100 people, level 3 charger will charge a car in a half an hour. So are we going to have a constant carousel of people? My half hour's up, I got to go move my car so the next person can move in, plug their car in. And the level 3 charger technology is still fairly new compared to the others. So that really hasn't been standardized yet. There's a lot of different manufacturers out there that make vastly different chargers. So the level 2 chargers, for at least for now, seem to be the best way to go. And then the other key piece of this here is the level 2 chargers for fleet vehicles, especially where they're not being used 24/7. They can park their car, plug it in, let it charge overnight, take a full charge, and it helps diversify the whole situation. So as we get into what's the impacts on a standard building? So one of our 10 buildings here with 100 occupants, based on the executive order that 50% of the EVs have to be, 50% of the occupants have to be driving EVs by 2030. We're looking at 50 chargers for that 100 occupant building. Now, each charger takes a 60 amp 2-pole based on the average standard of a level 2 charger. So for 50 chargers, we need 100 poles of electrical space. The government standards right now is 15% spare capacity. So even in a brand new building, you're going to be very hard pressed to find 100 poles of spare capacity to land 50 2-pole breakers. The other is at 11.5 kW per unit. The existing building will see an average of 50 times 11.5 is 50 times 11.5 is 575 kW, or in a 208 system, roughly 1600 amps, 800 or 700 amps of 480. Either way, you're at 575 kW. Most buildings looking at 100 occupant load is probably in that 20 to 25,000 square foot range. Usually they'll have somewhere in the neighborhood of a 1600 amp service on their own at 208. So we're looking at essentially doubling the capacity of that building for what it's going to see. One thing with chargers right now and EVs, because it's a newer technology, the code truly hasn't caught up to assign any kind of diversity factor to EV charging. There are some things that can be done, but for the most part, you're looking at absorbing that entire load into your calculations. So, we're looking at taking a 1600 amp service in an existing building and adding 1600 amps to it. Again, using that 15% spare capacity on a 1600 amp service, you're 240, 250 amps. It's nowhere near what these things really are going to take. And that is the underlying main issue of what we're up against here. So taking that building times 10, because we have 10 buildings on our campus, our campus is powered by a 12470 loop in our assumptions. So a normal size campus loop for something like this would be a 200 amp 12470 loop, whether it's fed one way or redundant, whatever, 200 amps. So 10 buildings, each of them, we're pulling the same amount of power on average, pulls an additional 5.75 megawatts of power on that 12470 loop. So at 12470, that's 269 amps. Again, roughly doubling the load that these buildings and this facility is going to see over the course of time based on the added chargers. And then as that infrastructure goes on, again, we have to deal with the utilities. Can utility handle it? Some can. Some have some pretty robust areas that have decent sized capacities. Others, as we're seeing, they can't handle what they have, and they're dealing with blackouts. So what can they do to even keep up with what we do to get the problem solved? And then the one piece that goes even a little further that I know always weighs heavily on the minds of facilities directors, and that sort of thing is what is the cost of this? So based on our little model that we've created, our first cost is probably going to approach the $25 to $30 million range. Once you include taking a building, increasing the size of the service, increasing the size of the transformer and the site distribution, doing whatever, trenching, backfilling, reclamation, all the parts and pieces that come into that primary system loop, and then dealing with the coordination of the utility. It's not a small pill to swallow on an initial cost. And then the cost that happens after that is, with our 10 buildings consuming 5.75 megawatts of electrical load, you calculate that through, and we're using 92,000 kWh kilowatt hours per day of electricity. So Me living here in Pennsylvania, our average kilowatt usage is 10 cents a kilowatt hour. And if you take that and calculate it out per a month, it's approaching $250,000 a month in additional electrical cost. So it's a very big ticket item, and I don't think it's something that many places have that sort of money and funding laying around. So overall, as we look at that, what does that mean to our utility electrical infrastructure? As a building, I'm taking a 1600 amp service in theory, and I'm replacing that either with a 3000, 3200 amp service at 208, or I take that 208 1600 amp service and I convert it to a 1600 amp 480 volt service. It still creates a footprint issue. The gear gets much larger, clearances get much larger. So can the building support it? Do we have to put an addition on the building to increase our footprint for our electric gear? Do we have to put our electric gear outside? Not ideal in most locations. I don't know about some of the other places in Pennsylvania here with the weather and stuff that we get. Outdoor rated gear does not last very long. So there's a huge issue there with just getting the infrastructure into the buildings. And then most facilities, especially in the military setting, they tend to have all their buildings backed up by some sort of emergency power system. Most buildings are 100% redundant, so it truly becomes unfeasible to back up a building that has a 3000 amp service just for car charging by a generator. You're taking a 400 amp generator, and now we're increasing that to a 800 to 1000 kW generator, and the price of a generator that size just to buy the machine could be $300,000-$400,000. So there have to be some type of decisions made there. Do we truly back everything up? Do we take the generator and turn off, shunt trip the feeds to the charger stations? Do we, that causes a problem if we have a prolonged outage? How does a military base move cars around that they can't charge? So there's a bunch of different scenarios that come in with that, and questions that need to be asked and answered. And then on the primary side, to take that to a 200 amp service, make it a 400 or even a 600 amp service, 12 kV. We have trenching, sidewalk crossings, roadway crossings, any kind of site features, conflict with other utilities, potential conflict, and getting connections from the power utility company. It all just kind of snowballs down the road and turns into one pretty big mess. But with that, there is a bit of a light at the end of the tunnel. So some first steps that we have found would be in the best interest of any facility that's looking to expand this EV. We currently are working with a very large project with Hertz. They have bought hundreds of thousands of vehicles, and they're spacing them over 60 plus airports all over the country. So they're doing a very similar thing to what this would have, force a facility like yours to do, except for little, different ownership, whatever. But what they've done and what we've been able to do for them is we developed it into stages. So we go in first phase, contract with a design firm. We go out, we do some load studies. We put some long-term metering on services for 15 days or a month. Look at utility bills, see what kind of diversity you have right now and what kind of capacity you have right now on your systems. Once we do that, then what we had done for Hertz, and it works well, is we go out and we install as many chargers as we can to use up that excess capacity and that diversity. So where we may need, and ultimately need 50 chargers, we might be able to power 10 or 12 of those chargers right now with what's available at the facility. We do that, get those installed, and the big advantage of that is it alleviates the pressure of, you can still charge your cars. It might be a little bit of a logistical headache for a while, but it gives you that temporary tourniquet on your issue so that you don't have to bite everything off at one time. And then while you're implementing that and having that installed as part of the design, we determine what now has to happen, the best way to upgrade those existing facilities, upgrade the existing service to a building, figure out how many chargers we truly need to get to where we need to be to meet the executive orders that are out there in place. And that becomes a phase 2 project that can be spread out over the course of several projects or several years, however it needs to be. But the initial, like I said, the initial tourniquet has been placed on so that there is an apparatus there as these fleet vehicles start to show up, as the public or the employees start to come into the facility. They have a place to charge their car for the time being. That really helps the whole funding piece of it. It's not, here's $25-30 million worth of work. We can look at it, we can pull it off in chunks. What can we do here? What do we have to do next? What do we do next? And so on and so forth. The other option that has a lot of merit to it is to explore an ESOP or an ESCO. We have had some success in talking with the ESOPs in going after potential work where the ESOP comes in, they meet a facility, you negotiate, sign a contract. The ESOP will foot the upfront bill. They'll pay all the upfront costs. They will install all the systems, install the chargers, and what they do is they want to initiate that green component. They'll investigate, what can we do with solar? What can we do with wind energy that helps offset all of that, which is the ultimate goal, right? Get off the power grid, get off the fossil fuels. So they try to integrate those components into the system, but they ultimately pay for the system up front. They pay all the utility bills that come in from as part of their contract, and they may perform all the maintenance on their system during the course of that contracted period, where the facility at that point pays their monthly, quarterly, yearly bill back to the ESOP over a long period of time, 15 years, 20 years, whatever it ends up being. So it takes that big inrush of, I need funding now for these projects, and you bring in a consortium where they take care of that portion for you, and they'll take care of the design. They take care of everything. They take over ownership. And then the last thing that we've looked into a little bit and does have merit, although it just adds more first cost, is for the bases facilities to go into their bases, explore their own solar prospects, explore their own wind storage, try to incorporate energy storage devices. If you can spread out your usage or your storage over a longer period of time, your demand factor goes down. Your power bills go down. You're using less electricity. There is more first cost depending on the system, but over the course of the time, that $250,000 a month in what could potentially be electric usage fees goes down to something much less, potentially zero. So there are ways to get around it. The best thing to do is to, if you can't do it on your own, engage somebody, get that initial study done, see what you have, see what you're up against, and get that master plan going, and see where it leads you. Okay. Does anybody have any questions based on all of that? I will do my best to answer.
Hey, Brad. Thank you so much for the presentation. We have plenty of time for Q&A, and the great thing is we have a very engaged audience today. I think this is the biggest webinar attendance we've had in the energy and sustainability, at least in the last year since I've been running the webinar program. I have 136 responses on the webinar poll, which is really great. 7 active duty military, 19 civilian government agency folks. Pretty even distribution around small business, medium business, and large businesses, about 30 to 35 in each of those categories. 5 from academic institutions and 8 retired folks. So I really want to thank everybody for joining the call. I think it's probably a testament to how much people really want to learn more about electric vehicles and how they can kind of help support the very ambitious goals of the administration around electric vehicles for federal facilities. I wanted to say as well, as we are, it's obvious people are interested in electric vehicles. The Energy Exchange, which is coming up in October in Cincinnati, it's October 25th to 27th, is going to have an entire track on electric vehicles and the conditions and challenges around them. So kind of a massive expansion of, wow, I don't know if I just got cut off, but it seems like I had a network issue. Everybody can still hear me? Brad, give me a thumbs up if you can still hear me.
I still hear you.
All right. Yeah, so as I was saying, hopefully I didn't get cut off too much, but the Energy Exchange has an entire electric vehicle track. That's 9 sessions coming up in October, including some of the things that I know folks are interested in with the QA, workplace charging, and personal vehicles charging. How do you select vehicles? How do you select chargers? How do you kind of begin the process of the master planning and electric vehicle planning efforts that Brad has laid out? So a lot more information out there. We'll get a lot more experts involved in the conversations, and I'm sure it will be a topic at Small Business Conference as well. So. Yeah, really a lot of interest in there, a lot of challenges. Go ahead, Brett.
I was just say we're for this presentation, I was trying to keep it high level enough to quote unquote open the eyes of there's more to it than taking a charger, plugging it into your system, which I'm sure most people know that. But how much of an impact that means on your facility, it's huge. It's absolutely huge from an electrical standpoint.
Right.
You don't get something for nothing. You either burn fossil fuel, which is a ton of energy, or you dump a ton of electrical energy into a car. You don't get both. So right. I was just trying to, this is what you're truly up against. It's a huge problem, but hopefully there are ways around it, and there's things we can do to mitigate it.
Yeah, and I think as you and I talked over the last few days, you made some assumptions for the presentation to kind of facilitate the calculations that you made. But when a facility manager starts to dive into what they really need to do to figure out how to meet the executive order goals, there's the electric distribution challenges, personnel distribution, facility condition, and 100 other factors that are variable and aren't kind of as easily washed away for easy calculation. It's a much more complex approach. Location of chargers, what kind of charge management tools you're going to use, software, policy. Funding. I think that's a huge one, and there's a specific topic at Energy Exchange around the kind of how do you take an unfunded mandate situation like this that is of high priority and actually make progress. Vehicle selection, future proofing. There's just a kind of an endless list of things to think about to effectively plan how to implement. I want to get to a bunch of the audience questions because there's like I said, amazing engagement right now. So I see Phil Hicks is out there. Hi, Phil. Nice to see you. Glad you could join us. I know he works for EPRI, I think, still, at least last I knew he did. He's saying make sure to get out there and see what the research that EPRI, that's Electric Power Research Institute, is doing. One of the SAME strategic partners around kind of research that they're conducting on behalf of the utility industry. So great advice. And then Phil has a question associated with that: is have we considered briefing or presenting on the ESTCP electric vehicle bases? That's the DoD's test bed program. He says he found a few of the 22 selected projects around electric vehicle infrastructure management and scheduling. I think that's a great idea. The speakers at the track for Energy Exchange are not finalized yet, but I'm sure that the ESTCP folks are going to be involved in presenting what they're doing around electric vehicles coming up. So thank you for that question, Phil. Let's see. I had posted, Bill Haight had something in the chat that I reposted here. Has there been any guidance around work interruptions as everybody goes out to move their vehicles to charge it? 2 trips per day to the parking lot for POV. Brad, any kind of thoughts on that piece of it?
Yeah, to be honest, I don't think anybody's really thought that part through yet. I think along with not even just government, I think just in general, as this stuff morphs and takes place, we're just initially finding all these facilities really diving into this now. So I don't think the policies have been written as to, part of the presentation was we almost like the level 2 chargers better because they do take longer to charge, where level 3 charger is great. It'll charge a car in a half an hour, but you're only putting 3 of them in versus 10. So what's the circus going to be with people running out there every half hour to move their car? I don't think anybody's really thought of that yet. I haven't seen anything as far as an actual guidance type thing that puts out there and says, this is how you should do this. I haven't seen anything yet.
Yeah. Bill Haight has another question here, and I'm not sure we're going to be able to really answer it directly. I know there's someone from Nextcom out there on the call right now, and I wish we could unmute to have them to weigh in. But the question is around what responsibility the government has to provide charging sites for POVs. I know this is it's a bit of a tangled situation. I know that all the fleet managers and facility managers out there are weighing what options there are out there. I know the NEX and AFES and other on base organizations have to some degree provided chargers, and I know that facility managers are really challenged to figure out what kind of policy or payment options, or how do you account for that fact that the government doesn't provide gas stations for POVs in general. So what's the responsibility around electric vehicles? I think a lot of questions there, and like I mentioned, there is a specific topic about this at Energy Exchange.
Yeah, one sort of related comment that I've heard from different people is to the point of the government doesn't supply gas stations. So why wouldn't the different facilities charge for the electric usage to charge cars, right? To the best of my knowledge, in talking with some people, as of right now, the different bases and whatnot, they don't have an apparatus to be able to capture it. So even if they would put a debit card slot on a charger that I could go up and swipe my debit card while I'm charging, there's no apparatus out there yet. Maybe this is something that's coming, but as of yet, there's no apparatus out there that allows the money that I pay in for that electricity to go to the base that I'm using electricity from. It can go back to the government somewhere, but there's no way to get it to that base to offset that cost.
Yeah. Speaking of offsetting costs, so you talked about in your presentation about the upfront costs and the additional electric related costs of installing EVs and chargers. But there's a necessary. You also talked about alternate financing and ways to fund the effort, which are necessarily based in savings, right? There's a very very real savings associated with fuel reduction costs and with less operations and maintenance and other things that go along with the switch. Any thoughts on how that can be leveraged to address the high first and recurring costs of taking.
Yeah, the big advantage with the ESOP area or the ESCOs is, an ESOP is it's a group of people, employee stock ownership plan is what it's called. So it's a consortium of people that have money. They invest it into buying your utility infrastructure for you, and then they charge you a monthly flat rate back for it. So they absorb that first cost. In most cases, they take care of all the maintenance, so you can defer all of your maintenance costs during that time period. They'll do all the utility interaction, pay those power bills, and you pay them one flat rate. Now, the advantage is obviously you don't have to come up with the first cost money, and you don't have to maintain that system for the first 10, 15, 20 years, however long that contract's for. And then at the end of that, once it's done, that ESOP goes away, and now you own that system. Now, if they come in and they add solar to the project as part of it, a lot of them will introduce the solar pieces and whatnot, because they want, where they make their money is you're paying them that utility usage that you would be paying in utility, but since they're generating that power from solar, they don't have to give that money to the utility company. And that's how they make their money off you. Now, once you're done paying off your tab to them, that becomes yours. So where they weren't paying the utility company, now you don't have to pay the utility company either. So if that system has a 20-year lifespan and your contract is 12 years, you paid them for the first 12 years. Now the next 8, you get to reap the benefits of that system.
Right, and just to tag on to that, I mean, describing I think what's kind of commonly known as charging as a service, right? Something that energy as a service and resilience as a service. I know that there are these as a service ideas and topics that are being chased by the federal government. I'm not sure there have been any real actual project put into place to implement that. I know the Air Force has been working on an energy as a service project at a couple locations for a while, and I know charging as a service is something that the federal government is going to be looking to implement as well. And I'll just say that I represent one of the ESCOs that does ESPC work, and clearly the savings potential there makes building electric vehicles into an ESPC a topic of interest. I think there are some challenges around the budgeting crossovers, right? Taking credit for fuel savings as opposed to utility savings, which is how the law is written. So we're working with FPCC and NAESCO to try to navigate that, to really make ESPCs a primary vehicle by which you could implement electric vehicle charging at no upfront cost, as Brad's describing. Let's see. I see a question from William Horton. So DoD needs to charge the customer for the actual electricity used, plus the development and maintenance costs of the system. I think that question was again kind of related to the POV charging. Any additional thoughts on that, Brad?
Yeah, Well, so yes, there's definitely merit to it. It goes back to the whole they don't pay for your gas, why would they pay for your electricity, right? And I think that's coming. They don't have, at least as of what we know today, they don't have that apparatus to do that. Whether they're developing that to get that to happen, I can't say. I can't see what they're doing. But as of right now, there just truly isn't a way in the government world to be able to charge you for that electricity and get that electricity bill to whoever you're using it from. So
Right.
is that coming? Most likely it's being developed or thought about at least.
So you talk in your presentation, we kind of focused on the idea of building through facilities, right? To have the charging kind of connected to a facility and connected to a building and its service. What are the thoughts of standalone charging station or stations kind of dedicated that might be able to have a dedicated transformer, infrastructure, purpose-built infrastructure installed to support that particular function?
Right. Well, there's pros and cons to everything, right? So obviously, if we build in case of our little exercise here, we put a 1600 amp 208 volt board outside, or in a little building on its own, and we power the chargers from that. That's an alternative. It's a very viable alternative versus going in and digging into the bowels of an existing building that may be 60, 80 years old. There's definitely merit to that, and we've done that in certain cases for different applications. One of the disadvantages to that, I guess I'll say, is it gives the facilities owners an opportunity, if they do have a 60, 80-year-old building, that the electrical distribution is at its life end, getting to that point. It gives them internally that ability to refresh that system and bring that up to speed as they're doing this EV charger project. So they're kind of killing two birds with one stone. Yes, there's pros and cons to both. The idea of running redundant services, it can be done. On the primary side, going through a campus, I sort of don't like the idea of that. It's just more maintenance, more places to fail, more utilities, crossing utilities, that sort of thing. But there's definitely merit to it, depending on what the situation is for each individual client.
Right. Brenda Trevino asks a question about, I know you had mentioned solar. She asks, has anybody looked into portable solar units to supply the power? They appear to provide another solution to the underground infrastructure situation, and may be helpful in smaller installations or other federal campuses that are on military bases.
Yeah, I think part of the problem there is, everything's developing and changing at the same time. EV chargers have come about, or EV vehicles have come about. They're being developed at the same time that the solar systems are being developed and designed and improved. And I don't know of a portable solar system that's capable of putting out the power that we're talking about to charge one of these cars. They actually, in Europe right now, they just came out with a vehicle that has its solar panels built into the car. It's actually built into the paint of the vehicle, and it charges the car as it goes. The problem is it has a top speed of like 14 miles an hour, and it has a total, I think I saw the total maximum driving range is like 4 miles. So it's just it's a prototype type thing that they're doing. I don't think the solar technology has gotten to the point where anything portable can offset what a charger produces. These things take a ton of power. Now, is solar a viable option for the overall facility? Absolutely. Depending on what kind of space you have and ultimately first cost you can afford to put into it.
Yeah, the technology question is really interesting too, right? I mean, I know in your presentation you kind of focused on the level 2 chargers, and you and I had a conversation about level 3 chargers recently as well. This idea that the target is 2030 and 2035. I mean, it's not that far into the future, but the pace of change of the technology just seems to be going so quickly. any advice as folks kind of think about, and I had mentioned future proofing earlier, there's a ton of infrastructure investment that needs to go in here. And there's a very real, threat or challenge of painting yourself into a corner and having a technology on your installation with all this infrastructure investment that's not good in the future. Any advice there for thinking about technology?
Yeah. So the way that we've approached it, and I can use the Hertz example that we're developing with them, is the fast chargers want to see a 480 volt service that has, most of them are a 400 amp input. So what we've been doing for them is where we are upgrading infrastructure, we're bringing that in at 480 volt, even though we know we only need 208 for our level 2 chargers. So if that ever does become an issue that they want the level 3 chargers, it's at least there for them. Now the capacity part is, it doesn't matter if it's a fast charger charging your car at 30 minutes, or if it's a level 2 charger charging your car at 8 hours, or it's level 1 charger charging your car in 17 hours. It doesn't matter. The same amount of wattage, the same amount of power is still getting used and put into your vehicle. So in that effect, it doesn't matter. It makes more sense for the places where people are coming and going more quickly, the convenience stores, gas stations, shopping malls, those sort of places where people are coming, they're getting their whatever they're going there for, and they're leaving. To have the ability to have a fast charger there, level 3, makes a lot of sense, especially when you can charge them for that. They're not going to sit there for 8 hours waiting for their car to charge in a level 2 charger. While you're going to an office and you're working, most people are in their office 8 to 10 hours a day. So you don't need that bang, here's a whole bunch of power right now, your car's charged. You just need to be charging while you're doing what you have to do. And it seems to make more sense for these type of facilities to stick with the level 2 chargers.
Right. Great question here from MK Baldwin. Not sure, again, we're going to be able to answer it really here. Has there been any discussion on putting funding in both the O&M and MILCON budgets to fund the studies and upgrades? Or is this, like many EOs, unfunded mandate, basically forcing bases to kind of figure it out on their own? I think that's that may be the case right now, but I would really love to hear from any of the folks working for the federal government or DoD right now to update on anything that may be happening in that space. I will say that as I keep mentioning the energy exchange track here. There's someone from the Navy, from NAFAC, is leading a session at Energy Exchange called "How to Balance Priorities in a Resource-Constrained Environment." That's the kind of the toned down title of that session, which he really wanted to call the unfunded mandate. How do you make progress in an unfunded mandate situation? So for MK and for everybody out there, I mean, I think that's a serious challenge. It's an aggressive and ambitious target that doesn't, at the current time, as far as I know, have any funding directly tied to it. I see Jim Plord is posting something here, maybe not related. So yeah, I think that's a big challenge. I think it's something that everybody's going to be facing and trying to solve in the future. And hopefully, sessions like this and other opportunities to kind of get together and talk through some of that will help shape the policy and funding and budget discussions around that.
Mm-hmm.
Let's see. Someone posted, can you talk about the financial implications of absorbing $25 million of first cost within a performance contract? Does this double the KWH charge, triple? Are there any models for this?
So it largely, in the work that we've done with it, it largely depends on the size of the project, the amount of energy that's being used and consumed, so it's the size of the facility, and then what the terms that the facility can agree with with the ESOP, whoever it is they're contracting with. If the obviously in the best interest of the facility would be to pay that money back as quickly as possible, so that term gets shorter. But where they have to, it's all negotiation. The ESOP has a target that they want to make a certain amount of profit. I'm sure that varies from ESOP to ESOP. And then, obviously the facility wants whatever they can do at the cheapest amount possible. So it truly comes down to a negotiation and what the size of the project is and what the terms have become. I don't know that there's an actual number for it.
Yeah, and I'll just say, the absorbing the cost. I mean, this is the primary challenge and benefit of ESPCs and UESCs and other alternately financed projects is this idea that you can finance that over the 25-year authority of ESPCs to absorb that. I think one of the challenges, as I had mentioned earlier, is really ensuring that these vehicles can take credit for the fuel savings associated with electric vehicle charging. You want to obviously, in order to be able to use savings to pay that upfront cost over time, you want to make sure you can take credit for all of those savings. Now, of course, there's shifting charging times, which you can do with EVs to potentially save money if you have a time of use rate, and other ways to work with the utility companies. And it's of course a very complicated calculation in this kind of situation to understand what the savings are and how you're going to pay for it and how it interacts with the other conservation measures you're going to build into a project. So great question. Not like many of these other questions, not fully answerable right now, but I think that the industry and a lot of people who are probably on this call and interested in it are working on driving towards solutions. Jim Plord, there's a name from the past. Hi, Jim. How are you? Asks, I'm interested in financial pro forma of embedding first cost in a performance contract. What does that financial model look like? I think we kind of talked through that issue a bit right now. Oh, and by the way, the SAME just tells me 179 people on this webinar. Awesome turnout. I think this is really great. Probably time for one or two questions here. Who asked this one? Fred Hussein asks, would this process apply for building charging stations for transit buses at a maintenance facility of a local transit agency?
Yeah, it's largely the same type concept. The buses, they're a little bit of an animal unto themselves. The larger buses, they have their own charging systems. They even come out with ones now that it works off radio. You don't even plug them in. You park them over a spot, and they self-charge over a platform. But the concept's largely the same. It comes down to, I have to take so much power from a utility or from some source and transfer it into this battery on this bus. The buses are a little bit easier in the fact that they have more period of time to charge at certain times. Other times it's much more difficult because they need that fast charging because they're constantly on the go. It's a little bit of a different animal, but it's the same overall concept.
Yeah. Well, like I said, I'm very happy to see so much involvement and engagement. There's probably, golly, 25 questions that we didn't get to. So I think it's a really good engagement. People are obviously interested. I am going to close with just a little bit of the energy and sustainability community of interest update. As always, if you're interested in serving on the committee, please reach out to Norm Campbell. You can see his email address there. We have another electric vehicle session coming up next month with the state of Colorado and some of the tools that they're developing with NREL on site selection and EV technology selection. We have other upcoming webinars this year on decarbonization planning, carbon capture, and other topics of interest. And of course, the Small Business Conference is coming up in Nashville in November. I'm going to put in one more plug for the Energy Exchange in Cincinnati in October. I'm heavily involved in that one and have been for years. And I think, final reminders here, I think there's one more, there's another, a link to the site for the Small Business Conferences. Registration opens next month. There's another webinar tomorrow on PFAS. That's another kind of I think in the environmental COI. That's the certainly one of the primary topics of interest. That's coming up tomorrow, and you can register there at that link. And just one more graphic for the Small Business Conference coming up. So thanks everybody for participating and being such an engaged and interested crowd. Thank you, Brad, for presenting your experience and calculations and thoughts on this. And we look forward to hearing more from you in the future. And I'm going to close out the recording and hope to see everybody next month. Bye.
Great, guys. Thanks, guys.